Hello, everyone, and welcome to our webinar. My name is Marina Silva, and I'm representing Integrated Global Services, or IGS for short. I'm joining you here from England, and just so we know that you can hear us and you can see us, could you please type in the chat where are you joining us from today? And I'll get this started. Great. In this webinar, we will talk to you about how to achieve CFB boiler reliability. We have several speakers throughout the event. First of all, let's say hello to Timo Aspelin, Director TMU Global Services at Sumitomo Foster Wheeler. Hi, Timo.
Hello, everyone.
Then we have Joel Taylor, CFB boiler operation expert with experience in 7 boilers across 4 power plants. Joel is not joining us live this morning, but his presentation will play later on. Then we have Ed Griffith, CFB boiler maintenance expert at Integrated Global Services.
Hello, everyone.
Hi, Ed. And finally, Ilkka Koskinen, Director Service Agreements and Digital Services at Sumitomo Foster Wheeler.
Hello, hello.
The presentations will take a total of 1.5 hours, and then we will open the live question and answer session with our speakers. You can type your questions in the questions tab on your right, and it would be helpful to note which speaker you are addressing your question to. And then we'll answer all of the questions at the end of the webinar. There is also an opportunity for speakers to type their answers before the end as well. Some housekeeping before we start. We are broadcasting live. If you experience any technical difficulties, try refreshing your browser or switching to the Google Chrome browser, or you can dial into the webinar to get the audio. And I'll post the dial-in instructions here. So you can call one of these toll-free numbers and you'll be asked to enter a dial-in code. In case nothing works, you tried all the options, drop me an email and we'll do our best to get you online. And if that doesn't work either, after the session, you will receive an automatic email with the recording. Just looking for the chat. I think you can see and hear us. That's perfect. So our first presentation will be by Timo. There's just a quick slide with his contact details as well, if you'd like to reach out for more information after the event. And we'll get started.
Hello, everyone. I'm Timo Aspelin, working for Sumitomo SHIFW as Service TMU Director. TMU meaning Technologies, Modernizations and Upgrades. And I'm today talking about our experiences on CFB boiler reliability. But first I want to introduce you who is Sumitomo SHIFW. Most of you probably knows us better as Foster Wheeler Company. We have a really long history on boilers, over 100 years. We are the leader in supplying of CFB boilers and having about 1/3 of the total fleet in the world. Sumitomo Group itself is 450 years old conglomerate from Japan. Our products are still concentrating mainly on boilers, fluidized bed boilers. Also, we have waste heat boilers in our portfolio. Those are for metallurgical processes. But we are widening our product portfolio to flue gas treatment equipment, and lately also we are developing our portfolio for energy storages for utility scale, and the first one is being the liquid air energy storage. We serve utility power sector and industrial sector in developing their energy systems, and now lately also we have been taking more activities towards waste to energy business, and we acquired a new technology for that, modular small scale waste to energy power plant. And we serve our customer base for all of those boilers and equipment that we deliver, and in different ways, from engineering and design to supplying parts, from spare parts to pressure parts and equipments, and then we have also now been developing digital services that you will hear more later today. We have a large fleet of delivered boilers around the world and over 500 CFBs, which is the base of our study for the availability and reliability that we will show today. This figure demonstrates how unavailability is divided into different parts of the power plant systems. Boiler plant having the biggest source of the unavailability, and we have divided this to different fuels, as we know that there is different fuels contribute to different problems, and some fuels are more difficult than the others. We can see that the refuse derived fuels, meaning waste fuels, those are the most difficult fuels to combust and bring a lot of challenges to the boiler plant. Here we can see how boiler plant availability is different for different fuels, as said earlier, and we can conclude that in average CFB boiler plant availability is about 98% if waste firing is not taken into account. Going deeper in the analysis of sources of unavailability, we can see that there is a difference also in boiler plant systems for the origin of the unavailability. We can see that the more corrosive fuels like biomass and waste fuels, they are causing also more problems on the boiler pressure parts. When digging again deeper into the sources of boiler pressure parts, unavailability issues, and mostly coming from tubic leakages, we can see that furnace walls are the most common and the most critical source of CFB unavailability when considering pressure parts. Here we have collected most typical reasons for tube failures in CFB boiler walls, furnace walls, which is always related to erosion or corrosion, or sometimes even those working together so that the wastage can be even faster. Erosion is typically caused by too high velocities in the furnace. This is related to maybe to overloading the boiler or changing the fuel that contributes to have more flue gases than the original fuel. Furnace walls out of plumbness, misalignment causes also problems for erosion point of view, because when the bed material is flowing downwards on the furnace wall, if it's misaligned, then the particles will hit the wall and the tube will start to erode. Maintenance errors might also relate to the local increased erosion of the tube. If there is any, if the shape of the tube is not grinded to be as close as original as possible, because this kind of discontinuities in the tube will start a swirl of material in that location, and the erosion will be fast there. On maintenance point of view, sometimes it is forgotten that after tube leakage there might be some material going into the tube during the maintenance or during the leakage, and then if that tube is not cleaned well, there might be a blockage of the cooling effect from the water flow in the furnace wall tube, and then overheating will result into a rupture of the tube. From corrosion point of view, most common issue is the reducing conditions in the boiler that is due to a poor air and fuel distribution and mixing in the furnace, so that it will cause the atmosphere to be more aggressive towards the steel and cause local wastage of the tube material. Also, ruptures of grid nozzles might cause local issues with the circulation and high velocities in the lower parts of the furnace, resulting in high erosion wastage in the tube. As we have learned now, the biggest reason for unavailability of the CFB boiler plant is tube wall wastage of tube leakages in the furnace walls. So how we can manage that tube wastage or mitigate it? Of course, first remedy would be to eliminate the erosion and corrosion by eliminating the root cause of that. We can correct the furnace wall plumbness, we can correct the air distribution, fuel distribution into the boiler, we can do some design improvements, and also we can take better care of when we are doing our maintenance procedures. But when those methods for eliminating the root cause is not for some reason feasible due to the time frame we are working on or cost effects, then we can use secondary methods for to protect from the erosion and corrosion. Seals we don't use in furnace walls because it would cause more problems, but those are used in the backpass on heating surfaces. But typically we use metal sprays in the furnace to protect from the erosion, having a hard surface on the tube. Then we can use also refractory, but refractory is not good to use extensively because it will also block the heat transfer of the furnace walls. And then for corrosion protection, we typically use weld overlay solutions, making the a surface on the tube that will protect the tube from the corrosive atmosphere. Sometimes we need some investigations to do to understand what is the reason for the tube leakage, for the erosion and corrosion, and we have a lot of services that we can provide on that one, from the visual inspection to laser scanning that will demonstrate the plumbness of the furnace walls. Then, of course, ultrasound wall thickness measurements, tube wall thickness measurements is really important part as well, to understand that what is the wastage in different parts of the boiler and how fast it goes on. We have also created those real-time digital services for the operation personnel to allow them to understand that what are the different situations of the boiler operations with different fuels at different times, so that they can understand more that how they are loading and running the boiler and prevent unnecessary issues of the boiler reliability. Here are a couple of examples of the reasons that could have been prevented easily on tube leak failures. On the left, we can see this weld buildups on the tubes where there has been earlier corrosion or erosion, and if those weld buildups are left like that, it means that there will be the swirl of bed material here on the top of the weld buildup, and it will actually the tube will start to erode on top of that really fast. On the other hand, when the bed management of the fluid aspect boiler is not good, then there starts to be a lot of coarse material in the bed, which results into higher erosion when the coarser material is getting in and eroding this lower part of the furnace tubes. Then one good example here is that there has been a tube leakage, and after that there is a lot of bed material in the tube. So if this is not cleaned up, it will cause rupture of the tube, as it has happened here. Now you can see that from the form of the rupture that there has been a short-term overheating due to the material from the earlier leakage in the tube. I want to thank you for listening today, and we are happy to answer any questions you might have later on in the Q&A session. Thanks.
Thank you for Timo's presentation. Just to remind you his contact details here on the screen, and he will come back to your answers at the end, to your questions at the end of the event. Our next presenter is Joel Taylor. Joel has a wealth of experience, and he operated 7 boilers across 4 power plants. And referencing a question from Uzair, he operated some lignite boilers too. So maybe we can get in touch with you after the event with more information on that. And Joel was actually interviewed by Ed Griffiths, and we'll play that for you now.
So Foster Wheeler has just spoke, and they've said
pressure parts are the most common reason that power plants fail. Can you describe how that relates to your experience?
Absolutely. So, the CFB boiler is going to be your leading cause of downtime for the plant. And once you realize that, then you can start, trying to wrap your mind around a maintenance strategy for the boiler. And it's not just looking at just tube failures, because in my opinion, I think CFBs are it's like a living organism. Everything is related. So your maintenance program, your scaffolding program, your inspection, the fuel, is all these items are all related, and you can't just look at just one particular item for a CFB. You have to look at it holistically. So if you change your fuel, that's going to change how maybe the erosion, or where the erosion takes place, or even corrosion. If you have fuel that has more ash in it, you're probably going to have areas that you've never seen have issues before with erosion are going to creep up on you. So it's almost a holistic view of what's going on, almost like the human anatomy, if you will, of trying to understand what's going on. What you're putting in, what you're pulling out, and how you're taking care of the boiler.
And throughout the unit, can you describe how the erosion took place at different rates all throughout the unit?
Yeah, so you need to understand how the erosion actually takes place. You can't just go into a boiler, stand on top of the nozzle or the grid, and look up and go, look, there's erosion. So you got to understand, first of all, what is erosion compared to corrosion erosion, and then where is it at specifically, and then why is it occurring? So, for example, it's amazing. You can get erosion on the roof of the boiler, and you need to understand why that's taking place. And it's not, what we've seen is it's not across the entire boiler, but mostly on the side walls towards the front, or in another unit, you might get it on the side walls towards the rear of the boiler. But you can't just go in and do a visual and see where this is occurring. We would get typically your highest areas of erosion are down at the lower combustor and at the refractory interface. And then different units have different designs of those tubes at that area. So you need to understand the design, what's going to happen when the ash goes down those tubes, and then how to make a proper repair, not only to the tube, but also to the refractory. I think is very important. And usually refractory gets left to the very last minute, whereas these guys should be involved throughout your whole planning process, so that you can look at it holistically as not just tube repair, but CFB repair, tubes, refractory, inspection, whatnot. That wasn't a very good answer, Ed, but.
And when I'm sorry.
Go ahead.
When you began to wrap your arms around the problem, so let's say that you're operating a boiler, you have some maintenance philosophy and program in place, but you realize we might be a little bit behind the curve. We're being a little bit reactive. So how would you come into that situation and start to ensure that you're breaking down the problem and switching from being reactive to proactive?
So it's super interesting. I had the opportunity to go to several plants, and two of them that I worked at were the fuel was extremely abrasive, very tough units. And I'll still say to this day that you should spend, if you do nothing, if you absolutely have a minimum budget, you should spend your budget on inspection, because you can't repair the boiler if you don't know where the problems are. And I've argued with budget people and maintenance managers over this philosophy. They're like, well, quit doing so much inspection and spend more on repair. Okay, where do you know to repair if you don't do an inspection? And then also your inspection can lead to future budgeting of future repairs. So not all repairs are going to be have to be done this year or immediately, but you're going to want to budget and plan out over several years. Typically, if I was to go into a new plant, what I'm going to do is look at all of the old inspection information. So when I'm talking inspection, I'm talking two different forms of inspection. First is the visual inspection done by your eyes, so you can see, okay, we've got erosion here. Don't know what the quantity of that erosion is, but it's there. I've got corrosion erosion on my rear wall at the cyclone inlets, for example, and then maybe you have leftover construction issues. At one plant we had the old welds left over from where they were hanging the water wall panels, and those weren't a major issue in the upper combustor, but in the lower combustor they were potentially leading to tube failures. The other inspection is the ultrasonic thickness inspection, which is going to be your guide. It's going to really tell you what you have going on, and you can't just do 1 point per tube. I highly recommend what I call a high resolution ultrasonic thickness. It's 3 points per tube, and you have to understand your boiler first of all visually, and you can have bands of ultrasonic thickness measurements at different elevations so that you can actually see what's going on. So for example, up in the upper combustor, maybe your bands are every 10 foot, but in the lower combustor, they're every 1 foot for maybe 15 foot. But that way you can get a beautiful ultrasonic picture of what's actually occurring in your unit. And I've seen it where you have almost zero erosion, and then it tapers in and then goes to up to 120 mils a year of erosion. But you'll never find that if you don't do the ultrasonic inspection.
And that's great right there. Can you speak to how you utilized having a team and how you brought in individuals from different backgrounds, maybe the benefit of them seeing different boilers, like obviously that's Bill, Shuey,
Right.
and then how you had internal team members and maybe they had different roles in the inspection?
Sure. So when you look at no one person can do this by themselves. That needs to be understood really quick. So you have to have a team of people. And so your team includes all of your crafts. So it starts with the scaffold guys, because if you don't have a beautiful scaffold to work off of, you can't do your visual, you can't do your ultrasonic thickness inspection, you can't do your boiler repair, refractory, and you can't do your cladding application. So it starts with scaffolding. And then on the inspection side, I always like to utilize a CFB expert, because this guy has seen other plants. He's been around this for 20, 30 years, and he can take his experiences from other plants, what they're doing, and bring that and help us out. And then typically, you get your blinders when you get stuck in the boiler for hours on end. And so you got to have somebody that is back away, like a project manager, so that this person can manage holistically the whole process from opening the doors to closing the doors, but that's not involved in all the details and the numbers, but can manage all the parts and pieces. And then you can also bounce ideas off of them, and they have enough knowledge of what's going on that they can speak not so much as involved in the day-to-day, but holistically. Like I might think that we need to spray up an area this year, but then he can go back and look, this area is progressing slower. Maybe we should focus our efforts over here. So it kind of helps with like a balance and checks system.
What about how, let's say, I always think of localized erosion, let's say at a tube offset, or if somebody did a pad weld, or if a gouge begins, it happening at an expedited rate. It's no longer at a linear erosion rate. Can you speak to that just briefly?
Yeah, so it's easier to do this on new construction or a couple of years post construction, where there's leftover issues from original field welds not being ground down smooth, poor alignment, and so typically a UT survey is not going to pick up on those items. That's going to be your visual. So you're going through, you're finding these, let's just call them welding flaws, if you will, construction flaws, and you have to understand why it was done originally. And a lot of times you can't find that information. So, for example, we had an area at the fill weld line about halfway up in the combustor that they had put these massive welds on. And when you're first looking at it, just straight on, you don't understand why they did that. But then if you put your straight edge up there, you can find out that the panels are actually offset into the boiler, and so they were getting erosion early on. So they went in and just well built it up instead of doing a thermal cladding. And so you typically go in your first couple of years of CFB life and you clean up all of these flaws, and you got to prioritize them because you can't do a million repairs, but you can maybe get a couple of thousand done your first outage, or you take care of the big issues first, and then you just let some of them wear in. But you can, it's amazing that you can get a weld on a membrane, and the ash is going to slide down and bounce off of it, get redirected right into the side of a tube, and you'll start gouging there. Is that what you're looking for, Ed?
Yeah.
Okay.
What do you see between different boilers and the consistency in wear characteristics, like specifically zones of the unit?
So it's super interesting. I've worked on 5 CFBs, and they're all completely different. Even 2 of the units, 2 different plants, almost the same make and model of boiler, act completely different, and it's all based off of fuel. So you can have one fuel where you have almost zero erosion, but maybe you've got some corrosion erosion, and then you have another fuel that it just eats up the boiler with the ash. And then I've even seen same unit, same location, and they opened up a separate mine or a new mine, started bringing in new fuel, and then all of a sudden the erosion characteristics change. But typically, if I knew nothing about your plant and I went in, I'm going to be looking at the lower combustor at the refractory interface. There's a lot of action there. You got all this ash coming down from the boiler, from the walls, and it seems to focus in the corners. So like your first 10, 15, 20 tubes from the corner that's easy stuff to go and find those areas. The next easy locations is cyclone outlets. So if your cyclone outlets are on the rear wall, you're going to get a lot of ash flow hitting the sidewalls and sliding down, and then also the rear walls. And then the roof seems to be a pretty typical spot for impact erosion, where we get a lot of wear.
And can you speak to methodical approach like bay maps and systematically working through the boiler and maybe making multiple passes through the boiler, first with the assessment, then with corrective action?
Yeah, so on the inspection side, you need to divide your boiler up, and I came up with this bay map idea because you have, say, 15 scaffold elevations, you got 4 walls, and 5 including the roof. How do you divide this up so that first you can get it inspected, and your inspection includes, like I said earlier, visual and your UT guys. Your cladding people need to come in, do their inspection. The refractory guys need to be also involved. And so then how do you bring all of this in? So it kind of came up with the bay map idea, and it broke it into small chunks manageable chunks. Typically by wall, by elevation, and then by bay. And instead of trying to inspect the entire boiler, just work on one bay at a time. And I think it takes a lot of surface area and it condenses it down to something that's humanly manageable for a person to comprehend, if you will. And especially on the cladding side. So when you're doing, back in the old days, the cladding guys would go in and they're spraying for days, and then all of a sudden, hey, we're done. How do you go and inspect this methodically to make sure that you have what you were hoping to get? And it's almost impossible. With the bay map system, you can do inspections daily, 2 or 3 times a day, and we can have super intelligent conversations about what's going on in this particular bay. So, for example, over in the right-hand rear corner, we've broken that up into a bay, and we can set a specific scope of inspection, repair, and cladding repair in that one particular bay. And it's easy to talk to that rather than going, holistically looking at the scope of work.
And can you speak to being like proactive and how you determine the wear rates? Felt like you had the wear rates plus or minus kind of understood, and then how you looked at, okay, in 3 years this area is going to be a problem, in 12 months this area is going to be a problem, so we need to be proactive now. So
I was fortunate to work with a software called Aware, and we were able to upload digitally our UT data onto an AutoCAD generated drawing, and it would put all the data at the elevation on the wall. And then that program has the ability to look at years worth of data and to come up with wear rates. So on year 1, obviously you have no wear rate. So year 2, you go in, for example, you take data, and then I made dummy data. So original wall thickness was my first year, or year 0, if you will, and then you overlay on top of that your UT data that you're getting from your high resolution. And every year you just start building up layers of data and then start generating these wear rate profiles. And so now you're looking at an entire wall, and you're looking at it into the future. So when I first get into a boiler, maybe you can only make a engineering judgment to be maybe 1 or 2 years out, but I eventually got to the place where I was looking 5 years out, and the data seemed to be very accurate as far as what was actually going on. And 1 year we were able to go in and validate the wear rate calculations, and we had gotten to a point where now we can actually plan. We can plan our repairs, plan the inspection, and the thermal cladding. So we're now able to budget years out. We're going to do 500 square foot in this area. We don't need to do it this year, but we need to do it in 2 years for sure, to protect the asset. So now you've gone from complete reactive maintenance, and you've moved into the proactive department, which when you do that, your life gets a lot better. You start having reduced tube leaks. Your maintenance budget starts to become balanced. You can actually plan for your maintenance budget, and it really helps out your entire team. And you get less surprises. Your UT guys don't come back to you and say, "Oh yeah, by the way, the front wall's falling apart," and all of a sudden you've got to scramble to make repairs and to install cladding. Now you're planning all of these activities out. The plant manager will love you for this.
Thank you, Joel and Ed, for this great presentation. We hope you learned quite a bit from Joel. And our next presentation will be by Ed Griffiths. And Ed will share his knowledge gained from approximately 500 boiler applications. And he will focus on primary reliability intervention designed to keep these boilers online and prevent tube leaks. He will touch on his experience with various metal wastage mitigation strategies. And over to Ed.
Good day, everyone. Thank you for joining us as part of our CFB boiler industry webinar. Glad to be joined today by my co-presenters from Sumitomo Foster Wheeler and our IGS's longtime client, Joel Taylor. My name is Edward Griffith, so I'm going on about 15 years in the industry myself. And the majority of my experience has come from CFB boilers, maintenance of, and interventions related to reliability. So my specific experience has been in project management of these applications that IGS completes. So assessing the problems in the boiler, determining the correct solution, project management of crews that come in and actually complete these applications, ensuring that they meet the specification that was designed, and the ongoing account management and long-term proactive look at reliability of these units. So I'll be speaking specifically to IGS's approach and look forward to talking to you today. So first off, who is IGS as a company and why are we unique? I thought it'd be appropriate to overview what are our core competencies. So we're 100% focused on reliability, and that being said, high velocity thermal spray claddings is specifically our 100% focus, and reliability across CFB boilers, but also critical power gen and processing equipment in multiple other industry verticals as well. In every situation, we're engineering customized metal cladding systems and solutions to complex metal wastage problems. So high temperature metal wastage, be it corrosion, erosion, is our purpose. We are very effective at client retention because we are able to articulate what we do and do what we say. We are very versatile under these dynamic outage situations. Outages change, boilers come offline unexpectedly, plant management groups change, and there's a need to be a chameleon and meet the client's specific goals as they continue to develop over time. We implement a turnkey solution, so we begin by assessing what is the exact problem that this client has, what are the contributing factors, how is it specific to this particular OEM boiler, or the maintenance philosophy at this plant. We design a customized solution to that, and then we have to live within the outage constraints in that particular project. Whether schedule is very important, whether budgets are very tight, whether there's other adjacent projects that are being completed, the specific demands on each specific project. So we take those into account, and that being said, implement a turnkey solution that takes into account all the critical success factors. And IGS only deploys experts to the field. So we don't only have special, fancy, and very educated people that sit in headquarters in special offices in the United States. These are we're sending the highly experienced industry veterans with the gray hair, with the lessons learned out to the field. They're involved with the crews inside the boilers, helping to ensure that we're able to meet the client's specific needs on each project. So IGS is a global company. We've completed projects in over 45 countries. So a bit of our global footprint can be seen on the map included on this slide. As you can also see, our research and development centers in the United States, our operations and resource centers throughout the globe. So these are global bases that allow us to operate with a local regional footprint while deploying a proven Western technology. So, be it North America, South America, Johannesburg, South Africa, the operations center that we've had in Japan the last 30 years, some of our newer operations centers in Southeast Asia, our traditional operations center in Europe. We are prepared to deploy folks from multiple centers, which has allowed us to have that characteristic of being versatile, being resilient when COVID demands obviously necessitate a need to be reactive under ever-changing dynamics. As you can see on the bottom of the slide, some industry leaders in terms of power gen, original equipment manufacturers, oil and gas majors. So these are leaders in their field. These are the type of company who can set the bar wherever they like in terms of who they work with, be it an expectation on safety performance, performance of the work, of financial health of the actual vendor, professionalism. And we're happy to say and believe it's a testament to the value that IGS provides, the fact that these are all people who've had a long relationship with IGS. So IGS deals with metal wastage in all forms. Specific to CFB boilers, obviously erosion is often the primary actor, but of course corrosion is ever present as well in CFB boilers. And then the combination of the two, corrosion erosion, can be an obvious accelerator for pressure part wastage. So in these boilers, IGS deals with the fire side of the boiler tubes, from essentially the lower combustor bed through the roof and adjacent to the cyclone, the wing wall panels, superheat evaporators, and obviously the metal wastage phenomena are not all equal. So throughout different parts of the unit, these metal wastage phenomena can take place at different wear rates. They can take place on one side of the tube and not the other. In localized areas, they can take place at an expedited rate instead of the linear erosion rate that adjacent zones of the boiler could be experiencing. So this is just a visual on the different wastage areas that IGS addresses with our high velocity thermal spray cladding systems. So starting in the lower combustor, obviously, this is a well-known wear zone in CFB boilers, be it the high volume of ash and fuel, the turbulence from the bed, the fluidization, ash being propelled airborne and sliding back down the tubes, transferring heat as it slides across the construction and field weld joints. Obviously, these joints, if not ground down properly, can be a site of localized erosion. Due to tube fit up and alignment, there can be localized erosion that changes tube to tube. where wing wall panels or evaporator panels penetrate the front wall, most commonly of the boiler, there is a sudden step change in direction of the ash flow as it's sliding down the tubes and reaches an impact point. This is a known site of localized erosion, and obviously another great point for high velocity thermal spray cladding to address that localized erosion. Adjacent to the cyclones, the roof area, and the front wall, the erosion phenomena changes to more of obviously an impact erosion rather than a sliding ash erosion that occurs in the lower combustor. So, you know, in this scenario, often higher wear rates. Again, the change in direction of airflow, ash and media in the combustion environment, impacting the tubes and abrading the tubes, and yet again another great opportunity for the utilization of thermal spray claddings to mitigate this erosion. So, what does IGS actually look like in the field while we are completing these projects? So, we'll start on the bottom right. This is just a visual of IGS actually applying the cladding material. So this is obviously in all the pictures we can see an attention to safety, PPE, full face respirator, so protection of the employee, and obviously consideration for a high level of professionalism and safety and respective of the client's risk profile. So specialized inspection techniques, measurability of IGS's materials can be evidenced from these pictures, you know, as well as multiple levels of QC in the top left of this picture. So, you know, these are the names of the multiple levels of IGS personnel in the organization and on the project team that have verified that the cladding specification that's been installed aligns with the specification that was determined is necessary to maintain reliability of the tubes in this location. So at a high level, what is IGS doing with these cladding systems? So if we think about corrosion, IGS is encapsulating the boiler tube with a cladding material that's non-reactive to the gaseous constituents in the combustion atmosphere that were previously interacting with the carbon steel tube surface. So in an erosion sense, we're again encapsulating the tube, and in this sense, the important part is with a material that is significantly more erosion resistant than the base tube material. So implementing a sacrificial barrier that is significantly more erosion resistant to the tune of 8 to 10 times more erosion resistant than the base tube material. So it's important to understand, you know, this cladding solution and the system that IGS implements. This shouldn't be considered an application. It's not a component, not a widget. You know, less of a project, not a transaction. But this is a solution that's the sum of its parts. It takes into account analysis of the problem, utilization of a very specific metallurgical profile, you know, of cladding technology, implementing a best of its kind and proprietary conveyance technology, as well as the people side. So people that are highly experienced in comparable applications, that are certified to operate this particular equipment, that are very familiar with the capabilities of these materials and the needed application techniques for CFB boilers. So when we start with analysis of the problem, you know, everyone's familiar with with wear on CFB boiler tubes. Also, UT data is a common data source. Combining that with a visual inspection is where we start to get into IGS's special approach. So first off, all the various wear zones of the boiler, as we saw in the previous boiler schematic, be it lower combustor, corners, wing well penetrations, field well joints, areas adjacent to the cyclone and on the roof, these all have their own wear rate. So determining in each zone what the wear rate is, as well as in different parts of the zone, the wear rate can vary. And then determining what specific cladding specification is necessary to meet the client's longevity expectations. So we want the boiler to operate for 3 years without a need for additional maintenance of this cladding. We want the boiler to operate for 18 months, but instead of our traditional 12 months of operation. Or we've been having tube leaks every 3 months and we want to extend out to operate for a year reliably. So these wear rates, these instances of poor reliability, observations of gouging, observations visually of different wear in each part of the boiler are what IGS is digesting and dissecting to develop a unique solution in terms of cladding specification. So in terms of materials, IGS's materials are all proprietary, not commercially available materials. So the IGS 8450 is obviously the material component of the CFB solution. So this is a material that IGS and material scientists have developed in-house that takes into account faults of thermal spray claddings throughout the years, be it being too erosion resistant and not having the characteristic of wearing down uniformly, or the need to be scalable over time, the need to be refurbishable. IGS's material was designed to take into account all of these characteristics and obviously excels in all categories while being more erosion resistant than other available materials. In terms of the IGS crews and the people, so these are people with well above industry average tenure. These are people who are trained and certified against IGS's individually developed engineering standard, which was developed because a comparable engineering standard didn't previously exist. So these are people who live inside teams, and IGS's organization is comprised and is called a team of teams. So when applications require a significant amount of coverage in a short amount of time, the number of teams is scaled up. The teams are modular, so we plug in more inputs to output more production, while maintaining the correct number and setup of quality controller to application technician to ensure rigorous quality control and control on the fact that the specification that was designed in fact meets what was actually applied in the field. These people are professional, and their level of experience, competency, and the bar that they're held to results in projects that are completed on time and safely, and for the client de-risks their outage and some of the other ancillary costs that can come from obviously execution of an outage. So just in closing, a final slide with some take-homes on IGS. So IGS has designed ourselves to have a local regional footprint. What does this mean for our clients? So it means ability to react in short order. It means support of IGS experts on the project. So installing a proven Western technology with a global reference base. So IGS's class of technology has been utilized in the power gen and the CFB industry over the last 40 years. So you can be confident that for IGS, this is not a test. The experts will be on the site, will react in short order, obviously under dynamic outage conditions. We'll complete a thorough condition assessment. So whereas other companies may function more as a painting contractor, where the client really has to take the lion's share of the condition assessment, of data analysis, of where to put the cladding, how thick to put it, and when it can be deferred. IGS takes some ownership of that process and provides guidance to the client, which that's guidance and experience that's been gained across hundreds of these boilers, hundreds of outages, multiple OEMs, different countries, different maintenance philosophies. So IGS can cater our approach to your particular maintenance philosophy as well as risk profile. And that being said, IGS has the expertise to recommend a proactive program to prevent tube leaks, to eliminate redundant maintenance, and eliminate maintenance functions such as welding and grinding that are going to create an indefinite effect on how the boiler tubes wear, localized erosion, and be problematic for the life of the unit. We're utilizing a high velocity thermal spray technology that is a significant innovation beyond the low velocity claddings that are utilized by other vendors in the industry. So what this means for you is better distribution of the critical erosion resistant components in the material. It means very dense cladding structure, which does not allow penetration of gaseous constituents through the cladding system. As I mentioned, for IGS, this is not a test. When we think comparable experience, when we think the paradigm of life that practice makes perfect, IGS is getting more opportunities to perfect our craft than anyone else in the world. So we've taken into account having the best technology for application, having materials that are customized for CFB, as well as having people and experience to know how to do this job. And the result for you is confidence and decreased total cost of ownership. There's no redundant maintenance, outages finish on time, and tube leaks are prevented. So ultimately, these are the move the dial costs. And IGS can give you a confident, proven solution to reliability. Thank you. Coming soon, IGS is excited about a new launch. We're very proud of our CFB solution. We have worked very hard, invested man hours, capital, working closely with many clients over time, and you've heard us discuss our solution. Well, we now have implemented our IGS Boiler Guard solution. That is a lifetime tube protection warranty in CFB boilers. There are some considerations in terms of specification, analysis, but with the client and IGS working together, IGS will be able to extend this offer to you.
Thank you, Ed. And our next presentation, and I'll just pull up his contact details in case you would like more information. And our next presentation will also be presented by Ed Griffiths, and it will specifically focus on how CFB boiler maintenance and reliability affects business profitability. He will touch on how maintenance philosophy can affect power plant profitability and how achieving CFB boiler reliability and skipping outages can actually boost profits by a quarter, whereas tube leaks, emergency shutdowns, extended outages will cause the plant to drop well below the baseline in profitability. And over to Ed.
Hi, this is Ed Griffith again. I'd like to have a bit of a discussion around total cost of ownership evaluation. So, as you're aware from my last discussion, IGS takes a very systematic and methodical approach to evaluation of these problems that take place in CFB boilers and mitigation of the metal wastage that's characteristic of these boilers. So obviously there's a cost associated with proven performance and such a methodical approach. There are significant cost inputs into the cost of these applications. Obviously from a client's perspective, there is an entire reliability equation that factors in risk, that factors in the cost of alternatives when evaluating a project of this nature. So first off, I'd like to speak to a couple of cases that have unique benefits that occurred because of thermal spray, some positive, some negative, and interestingly enough, these have some really move the dial total cost of ownership impacts. So in this first case, IGS began working at this plant in 2019. At that point, we actually had taken over from another vendor. So the plant had been working with that vendor for 3 years, and they were still having tube leaks. So they were spending money to have their boilers protected in an attempt to be reliable, and still, unfortunately, we're having tube leaks. So since IGS has been engaged and been helping this plant to take a proactive approach to reliability, we've been able to get the boilers to where they run 18 months continuously. So whereas before they attempted to run 12 months and weren't able to be reliable for 12 continuous months, now IGS has taken them to where they plan and actually operate for 18 months. So now, over the course of a 3-year period, they would skip one outage. So significant savings for them in terms of being able to skip an outage and a impact on their baseline profitability. So next case is a plant that I personally have worked with for a very long time. Prior to sort of expanding IGS's scope within the plant, they were experiencing boiler tube leaks 1 to 2 times a year. They were using minimal thermal spray coverage, and at the time, a lot of their boiler tubes had reached critical limits. So they were at the point where they were going to have to decide to protect these tubes, to replace these tubes, and we're reaching that point. So they expanded IGS's scope, have since levelized maintenance spend, have eliminated boiler tube leaks, and they consistently operate, depending on the year and depending on the specific financial case, for 12 to 18 months. But they can do that predictably and confidently because of the utilization of the thermal spray technology. So the main savings that they achieved was preventing that unplanned maintenance that was in addition to their planned maintenance. The third case I wanted to talk about was a plant that we were working with for several years, 7 years to be exact. Their management team had put pressure on them to optimize spend in the final years of the plant when economics were challenging at the plant. So they were unfortunately, one of the tough decisions that they had to make was to use a unspecialized thermal spray vendor that during that particular application was the cheaper bid. So the additional effects on total cost of ownership for them at the time was that thermal spray vendor did not finish the project on schedule. So the additional outage days required were unplanned, took them over the outage budget, and they weren't able to get back online and operate, which are obviously where the big impactful money is made. Additionally, the scope was not completed and the boiler was left at risk for that year. So, they made the investment, they took the extra outage days, which were costly, and still didn't get done the planned scope. So, in addition to cladding performance, obviously the professionalism of the vendor and their ability to adhere to the schedule to react under dynamic outage conditions could have other perimeter costs associated that affect total cost of ownership with regard to these projects. And lastly, another CFB in the U.S., this plant had utilized an unspecialized vendor unknowingly for the first couple of years that they had utilized the class of technology. So little did they know, things weren't going as well as they believed. The claddings had worn down over time. The vendor had not done the necessary maintenance to extend the remaining longevity, to refurbish these thermal spray claddings when they had worn down over process of operating. And when they opened the boiler in 2016, they had 500 weld and grind repairs to do. So the effect was a significant extension to their outage, being weeks to complete the additional discovery repairs. So significant impact to planned profitability because they weren't able to operate. Additionally, the cost of completing the repairs was costly, but after switching to IGS, we were able to eliminate all of those weld and grind repairs in the course of 1 year and have since continued to be their vendor. So, they got back on track and things have gone well for that facility, but unfortunately, there was a significant expense until that point. So what is the cost of poor quality, and what are the other factors that attribute to total cost of ownership? So, paying for protection, utilize an unspecialized vendor, and the protection either wears off before the planned date. Maybe it's covered by warranty, maybe it's not. But the big factor associated is the time. The vendor's not going to pay you for the time that you have to spend unplanned to complete additional repairs. Gouging into your tubes, tube leaks, collateral damage from those tube leaks. These are effects that would need to be repaired over time and will indefinitely affect the boiler tube condition, how the tubes wear, the contour of the boiler tubes, which inevitably will cause localized erosion and which will wear at an expedited rate for the life of the boiler. So cutting and replacing tubes, doing pad welding, weld and grind repairs, these things will inevitably affect the boiler tube contour. The localized erosion that will take place in those areas with or without thermal spray will have an effect on how the boiler wears and your systematic maintenance and localized erosion for the rest of the life of the unit. This is an example of that. So why does all this matter? With power purchase agreements, often there is an opportunity to pass through, buy power off the grid, still fulfill your contract. But unfortunately, now you'd be buying that power at market rate. So the profitability that's left on the table for those days of forced outage is, of course, costly. Minimum duration of a forced outage is probably 10 days from steam to steam, 3 days to cool, 3 days to come back online, making access, completing the repairs, vendor availability. Obviously, this leads to unhappy managers, unhappy plant ownership. That's obviously something that can be prevented, but we just have to take the approach of looking at total cost of ownership. What are the trade-offs by utilizing an unspecialized vendor? Are the trade-offs, going to be additional outage days? And how is this going to affect our facility over the next 5 to 10 years? Because when we think of a power station, and let's say a baseline profitability route, and by doing maintenance the correct way or the incorrect way, we can either sink far below our baseline profitability or have some opportunity to exceed that with levelized maintenance, proactive maintenance that allows us to, one, operate reliably and meet our profit goals, or defer outage work and have the opportunity to go after work when it's in plan, when it's in budget, and when it's correctly attributed to capital expenditure, for example. So when we think about the other factors that contribute to total cost of ownership, obviously first and foremost, I've mentioned that IGS specializes and focuses on boiler reliability. So that is first prize and probably the most impactful move the dial aspect of total cost of ownership. So as mentioned, IGS has a proven expertise in making these boilers reliable. From the efforts that we've made to be very professional, having a skilled and experienced team, that's where we can prevent those unexpected extra outage days. By understanding how these boilers operate, by having an extreme awareness of the capabilities of the materials, we know what tweaks need to be made so that we can prevent unexpected maintenance, which would incur extra unplanned outage days. Delaying other contractors, is never good for an outage. Of course, there can be penalties associated. Safety incidents, equipment damage on your site, those things can be significantly impactful and affect who would be interested in working during these outages. If you're unable to complete certain project scope and put the tubes at risk, maybe you got a cheaper project, but maybe you weren't able to protect all your risk areas of the boiler. Doing rework, as I mentioned, maybe some unsatisfactory quality application is covered under a warranty repair, so there's no direct cost associated for the rework. However, if you have to spend 4 to 5 days allowing the vendor to complete the rework, there's of course a cost associated for you not operating during those 4 to 5 additional days. What's the quality of life like at a plant? In plants that we've been in that have been experiencing poor reliability, they have a difficult time maintaining strong employees because quality of life is not good if you're in tube leaks and outages all year long. The loss of reliable reputation for your power purchase agreement customers, having a power plant that's unreliable and you being an unreliable producer for their necessary steam and electricity, could be a threat to future sustainable business. And obviously government penalties in some countries. So, when we look at all these other factors to total cost of ownership, there's a lot bigger story to tell than the cost of an initial one project versus the other. And who do you want to put the financial success of your business in their hands? The experienced, proven vendor or the cheap guy? Thank you.
Thank you, Ed. And our final presentation of the day will be delivered by Ilkka Koskinen, Director Service Agreements and Digital Services at Sumitomo Foster Wheeler. And his presentation will focus on digital advanced analytical services to provide boiler users real-time recommendations to help operators maintain their boiler condition and to understand where to put emphasis on maintenance planning. The presentation reveals how these online and real-time analytics can be delivered to plant operators and describes the contents of analytics that can be used to improve the boiler production and availability. And over to Ilkka.
Hello everyone and welcome on my behalf. My name is Ilkka Koskinen and I'm heading globally SFW's Digital Services business line. First of all, I have to apologize that some slides are heavily faded because certain things cannot be revealed before our official digital launch, which will be held after this summer. I hope this presentation will be a kind of a teaser that you should stay tuned and wait for our official launch date. So let's go and find out some key information. Our digital services offering is following. We have 3 different streams: industrial analytics platform, data collection services, and advisory services. Industrial analytics comprises 4 analytics applications, which are targeting to improve boiler performance and reliability. We have envelope, bed management, fouling management, and leakage detection available. Data Explorer, reporting, and alert management services are currently under development, but will be launched soon. Data collection services is typically based on our Edge IoT device, which is needed to get data flowing from DCS system to the cloud. Advisory services will complement, as there will be always need for an experienced professionals who can help and support customer to ensure good customer experience. This slide is illustrating the main principles how our analytics are operated in our cloud environment. On the left-hand side, you can see plant and boiler, which can be connected in SFW operated cloud. All our analytics services are operated here, and actually cloud computing power is enabling this kind of heavy online analytics. Earlier, this kind of computing would have needed a supercomputer, but nowadays it can be done cost efficiently in the cloud. User authentication and data storing is naturally also done in the cloud. Advisory services are provided remotely, but our experts are relying on cloud-based data. As you can see, data flow and cloud computing capability combined with our extensive boiler process knowledge creates a perfect match for this kind of industrial analytics platform. Envelope. Maximize boiler performance and stretch it even beyond 100% MCR level. But the coolest thing in this application is that you can do all this safely. Our analytics will take care of all critical parameters, including emissions, and guide your operators how to operate boiler and take the most out of the asset with variable fuel mix. This will also help all operators to understand boiler process in same manner, and it will unify the total operating style when analytics is helping them to make right decisions at the right time. Bed management. This excellent analytics which has already proved its functionality and prevented shutdowns due to bed agglomeration. This is the right choice in case you are planning to expand your fuel portfolio toward cheaper and more demanding solid fuels. This analytics will also help you to optimize bed material consumption and/or recirculation. Here in Europe, many customers are trying to minimize bed material consumption, as you need to pay the intake of material, but also disposal. However, you should always understand the real condition of your bed in order to maintain good operability, especially important in all CFB boilers. Fouling management. Fouling management is used to optimize your boiler soot blowing cycles. Main purpose is to avoid any unnecessary soot blowing and thus minimize steam losses, but also to minimize maintenance cost of equipment. Every soot blowing cycle will cause wear in many equipment. Steam valves, soot blower lances, soot blower supports, erosion shields, pressure parts, etc. According to our experience, there are many boilers which could be cleaned less compared to their standard practices. Now we are offering analytics to optimize your cleaning cycles, and simultaneously we can enhance boiler process knowledge of your operators. Leakage detection. We all know that unfortunately leakages do happen. Some of those leakages can be really expensive, especially if they happen, for example, in a hot loop superheater. High steam values together with hot solids bed material is not a good combination, and secondary damages can escalate very fast. So that's why advanced analytics are helping plant operators to react faster and thus minimize any secondary damages in pressure parts. This might have saved those critical minutes or hours which can cause a lot of damage and a long unplanned outage. Data Explorer service. This is a very helpful tool for our experts to remotely check data from plant DCS. This allows fast troubleshooting capability to see and understand what has happened there at the site. This is a cost-efficient way to get advisory services to support your plant operators. Reporting services. Those will be used to provide real-time reporting capability. This is a handy tool as those reports can be tailored pretty easily for each individual need. So, here are some highlights of our digital services. First of all, our long accumulated experience of fluid bed boilers and modern IoT applications are enabling this kind of services without heavy investments. There is a subscription fee based on how many analytics services will be used. This is applicable to other OEM boilers as well, not only SFW boilers. Typically, existing instrumentation and IOs are just fine, but of course this needs to be checked first. Digital services can be taken into operation within few weeks, but actual delivery time must be estimated case by case. If you are aiming to enhance your operators' understanding about the boiler process, this created a perfect foundation for that. And finally, if you would like to improve your boiler performance and reliability, please contact us.
Thank you to our speakers for excellent presentations. We would like to now welcome you all back on stage for a panel discussion. A lot of the questions have already been answered. And we'll start by Ed, thank you for joining us again. If you would like to pick a question that maybe you have already answered and just go through it for the group, and then we'll wait for more questions to come and more speakers to join us.
Sure. So one of the questions asked, and I'll give the asker opportunity to maybe clarify if needed, but there's a question about the sacrificing material like a metal spray. So just wanted to point out, so the high velocity thermal spray cladding system is a sacrificial system, obviously, albeit it's significantly more erosion resistant than the base carbon steel boiler tube. So, you know, if the boiler tube is wearing at a certain rate, then the cladding will wear at a rate that's 8 to 10 times, as an example, less than that. So, you know, it's designed to wear down uniformly over time and to be refurbishable. So it takes into account the need to be highly erosion resistant, as well as the ability to be worked with in the future.
Thank you, Ed. We'll go over to Timo. Is there a question that you would like to highlight for the group that maybe you have already answered?
Oh yes, there are quite a lot of questions related to corrosion issues and erosion issues as well. Some, but for the corrosion protection point of view, it is always a combination and compromise between design, protection, material selection, cleaning solutions, additives. So it's a really complex behavior when defining that how the chemistry works in the boiler. The combustion process has more than 200 different combinations of chemical components combining together in different temperatures and different speeds. So we have maybe the best knowledge of that in the world. We've been working on that field for so long that we know how all this corrosion phenomena has happened. So we can provide the solution, but it's really difficult to give a exact answer on your questions without having really a comprehensive understanding of the boiler design, of the fuel, and all the other items affecting on the issues.
Of course. Thank you very much for that, Timo. Now we'll move on to questions that haven't been answered yet, and we'll go through them one by one in order of appearance. And we'll go to the person that the question was for, but if another speaker is able to weigh in after, you are welcome to. So the first question's for Timo from BJoy. Have you used IGS tube coating services for any of your biomass CFBs? And if yes, then which location?
I have to honestly say that I don't know if we have used in biomass applications, but we have several units using IGS thermal spray solutions in CFB boilers. We are not typically using those. It's our boiler owners that are actually using those, but this is part of our cooperation nowadays, that to achieve the highest availability and reliability, it's always a combination of the boiler design, the operation maintenance where we can help, and then of course the protective methods. And we see that there is for sure a place for the thermal spray to be one part of the high availability, so securing the high availability of the CFB boilers.
Thank you, Timo.
I'll just add to that, Marina, and thank you, Timo. There is at least one Foster Wheeler CFB. Actually, there are two sister units at one plant operating since 2014. They burn biomass, being forest biomass, for a percentage of their heat rate. So there's a blend of coal and biomass. So you do experience the corrosion erosion phenomena in the unit, as well as obviously the significant erosion. Both those units are above 300 megawatt, and they use high velocity thermal spray adjacent to the cyclones, along the field weld joints, upper combustor, lower combustor, very comprehensive throughout, and obviously still have quite a bit of interaction and guidance from Foster Wheeler. So it is a U.S. case. So yeah, just a bit of background there.
Thank you, Ed. Our next question is again for Timo. How do we avoid fluidizing nozzle plugging and erosion? From Andrew.
It's good bed management. That's quite clear answer. Just take impurities out of the bed and keep adding good material into the bed. So then you will avoid the erosion issues. And if you have waste-derived fuels that will start to corrode the nozzles, then we have different solutions for that.
Thank you. We may have a question in the chat from Gopesh. Why in the boiler second pass, hard deposition? How can we overcome this? So it sounds like a hard ash deposition in the second pass of the boiler. Who would like to take this question first?
Second pass fouling issues. Again, very dependent on the fuel, cleaning methods, additives that you're using. There are many solutions to mitigate that, the fouling issues in boiler.
Ed, would you like to add something about fouling in boilers?
So related to pulverized coal units, IGS utilizes a specialized surface solution to mitigate the adherence of slagging and fouling The limitation in the second pass would often be adequate access, but yeah, that gives an idea. So it prevents some of the chemical bond that takes place between the slagging material and the carbon steel boiler tube. Isn't, it's non-reactive to IGS's solution, and thus low surface tension and inability for the slag to adhere. But yeah, and maybe not as applicable for CFB second pass.
We'll actually be running a webinar specifically focused on slugging prevention in mainly PC boilers, but any boilers that experience slugging. That will be in about a month. We'll be in touch with further details. We have a Q&A going between the attendees as well at the same time. Oh, we have another question. From Deborah Brata. What is the minimum oxygen level we can operate in a CFBC? Who would like to take this question?
Can you repeat?
What is the minimum oxygen level at which we can operate in a CFB?
I would say that it has to be over 0. You cannot go, of course, even to 0 anyhow. This is against the chemistry, but typically in pack pass, you're running the boiler in 2 to 3% of over air, so oxygen content in wet basis. Then, but the most important issue is that you have to remember in big CFBs, the mixing of the fuel and air has to be good enough so that the oxygen level is sufficient in every part of the furnace, every part of the back pass. Otherwise, well, typically in the cyclone, the mixing is happening already so that it's evened out. But if you have reducing conditions in furnace close to the walls, that will certainly start a corrosion phenomena on steel tube, and this is maybe you cannot even notice that it's corrosion phenomena because the erosion is eating the corrosion products away from the tube. But then you will certainly find excessive rates of tube wastage. So I would say that from the back pass measurements, flue gas, oxygen measurements, you cannot tell the whole truth of what's happening in the combustor.
Thank you, Timo. This is a bit less of a question. It was an answer to another question by one of the attendees, but maybe Ed can comment on that. So in your presentation, Ed, you showed a schematic that highlighted common wastage areas within the boiler. Would one of your suggestions be shop applied thermal spray in these areas? Or would it be still difficult to predict until your boiler actually goes into operation where your wastage will occur? If you can just talk about that for a bit.
Sure, thanks, Marina. And I actually did just write a bit in the Q&A section of the portal here as well. You know, we have done some shop applications in discrete locations. For instance, Joel said during his Q&A presentation piece that almost every CFB boiler experiences wear in the lower combustor. You know, often the height, the expanse, the wear rate is difficult to quantify until the boiler is operated and then the wear zones throughout the rest of the combustor, you know, obviously even two identical units burning the same fuel have different wear characteristics, wear rates, and wear zones, you know, whether wear exists in that zone or not, and as well as the breadth of wear in a particular zone is going to vary unit to unit. So be quite difficult to really accurately predict exact wear zones, and thus, you know, kind of invest and go after those prior to boiler operation. So, you know, that's part of obviously the special sauce of what IGS does is, you know, the analysis once a boiler is operated and through the early stages of commissioning, the analysis of wear, determination of wear rates, determination of, you know, the particular zones relative to that unit, and then we develop a customized specification so that we ensure, you know, an adequate amount of thickness is installed in the correct zone, as well as, you know, where it's not needed, we're not wasting money or time covering those zones. So short answer, shop applications have been done, but it is certainly not the traditional course.
Thank you, Ed. Next question from Claudette. What standard do you recommend in maintenance, monitoring, or repair of boiler tubes?
Sorry, can you just repeat that question?
What standard do you recommend in maintenance, monitoring, or repair of boiler tubes? I'm assuming it's in reference to known engineering standards.
Yeah, so I think probably a little bit of the answer can come from Timo and myself. You know, we're familiar with people maintaining to the American Standard of Mechanical Engineers. You know, there's obviously kind of plant to plant, there's different standards, different criteria. Some of it's been learned the hard way, and some of it is more the by the book engineering standards. In turn, you know, Joel spoke a little bit to individual maintenance philosophies and analyses. You know, I think every plant takes a little bit of a different approach, and you know, obviously based on their risk profile and the consequence of failure as well. Timo, can you add to that, please?
Yes, it's varying a lot depending on the country, depending on the customer environment in general, the expectation of feasibility, cost of labor. All these things are affecting a lot at what kind of standards and procedures are in place for maintenance. We have a long list of different protocols that we can provide and recommend that this is based on our long history. I'm not sure if we are following an exact maintenance standard. It's more about the best practices.
Thank you, Timo. Next question from Michael. What combustor velocity will provide minimum erosion rate at the furnace, aside from the bad characteristics? Timo, would you like to take this one?
Minimum erosion rate at the furnace, aside from what combustor? I would say our design limit is 5 meters per second. Mm-hmm. We don't design over that. Erosion might happen also with lower velocities depending on the ash qualities, the corrosion phenomena, additive qualities, how sharp the particles are and such. So it's it's a combination of many things. But yes, we don't recommend to cover all 5 meters per second.
Thank you for that, Timo. While we wait for any last questions, we'll be wrapping up in just a few minutes. I would like each speaker to summarize the event for us, so to speak, and maybe leave our attendees with some final thoughts. Who would like to go first? I might go to Ed.
Well, yeah, I'd like to thank everyone for joining us. And just reiterate, IGS is a global leader in field installation of these surface technologies to address wear and CFBs. Specifically our competitive advantage is the ability to have a local footprint, capability, technology advantage with HVTS and specifically materials designed for CFBs. The expertise that we have in condition assessment of wear locations, specifying the right material at the right thickness in the right locations, and 35 years of CFB experience to substantiate that performance. So, you can be confident that this is not a test for IGS, and, we'd be glad to help. So thank you again.
Thank you, Ed. And now over to Ilkka and Timo. And I must say, I appreciated your earlier comment about the partnership that is required to ensure boiler reliability. So maybe you can reiterate that fact as well.
Oh yes, as I mentioned earlier, it's boiler availability is reached by a good design for certain fuel. There are a lot of factors, not only the pressure part design, affecting on these issues. We need to remember that there is more than 200, typically more than 200 providers to make a power plant. So there are a lot of different auxiliary equipment that is needed for that. There's a lot of detailed design issues to be taken into account, and it's always combination of design and material selection and this equipment selection and protection methods and so on. This is, of course, you have to consider the feasibility of what kind of solutions you can actually consider, depending on the time frame that you have available, and also on the cost that you can bear. So it's always a compromise and combination of things. And the message here is that SFW, we can help you on reaching the highest availability for your boilers. And of course, IGS can also provide the best solutions for metal spray protection.
Thank you, Timo. Ilkka, do you have something to add, please?
Yeah, I just want to thank you for the audience and to add on Timo's and Ed's comments that we can also provide these digital solutions, and we are launching those after this summertime, so please stay tuned.
Thank you. And for our attendees, when we finish the event, if you would like to continue your discussions, you can do that in the LinkedIn CFB Boiler User Group. And I'll just post a link again in the chat. You are all welcome to join. There are no post approvals. And we can have a good discussion going. We will be running this webinar again later on today in about 4 hours, and then in 11 hours again for different time zones. So if your colleagues in different locations were not able to join this session, they can join the next one. And I'll just post the registration page in the chat one more time. And the contact details of all of the speakers are in the chat as well, if you'd like to follow up with more specific questions. And having said that, thank you all for attending. We hope you learned a lot of useful information at this event, and have a lovely day.
Thank you.
Thank you. Bye bye.
Thank you. Bye.